Now, our class for today based on viscosity. And don't forget, in our last class, we discussed about solid friction. And that's why I said we have two types of friction. We have one between solid surfaces in contact. We call it solid friction. But because the one between liquid and gas, we call it viscosity. So today's topic, we are going to discuss about viscous and non-viscous liquids. Force on object in the viscous liquid, then terminal velocity, effect of temperature on a viscous liquid, then fact about viscosity, similarity and difference between friction and viscosity. Now, let's start. When we say viscosity, we mean the force or frictional force between a layer of fluid in motion. And don't forget, fluid divided into two. We have liquid and gas. So you can still define it as a frictional force between the layer of liquid or gas in motion. Now, which means under this one we are going to have two types of liquid. We have one that we call viscous liquid. We have one that is not viscous. When we say viscous liquid, we have one that have a high frictional force, such as oil. We have engine oil. We have gear oil. We have our red oil is also viscous liquid. We have one that is not, some liquid that are viscous. Example, we have water. Water is not viscous. Then we have kerosene. Kerosene is not viscous. Now, what are forces acting in a liquid and on object inside a viscous liquid? So let's try to see whether there's difference between object moving in a viscous liquid and object moving in non-viscous liquid. I have two types of liquid here. We have water, which is non-viscous liquid, and we have engine oil, which is viscous liquid. Let's try and see what will happen when an object is moving inside both. So 1, 2, go. You can see that in the non-viscous liquid, which is water, it moves faster than viscous liquid because of frictional force. Now, how many forces are acting on an object as it's moving downward? So let's say we have our viscous liquid that is oil like this. Then we have object moving downward inside it, like what we just did. The weight of object is acting downward, W, which is same thing as mg, where m is the mass of the object, then g is acceleration due to gravity. Then we have frictional force acting upward, or we call it drag force. Let's call it what? V. That is not only force that's acting upward. We have another one. We call it upthrust. Upthrust is also acting upward. Now, under this now, it is clear that we have two forces. One that is acting upward, there are two. Then we have weight acting downward. So, the only condition that can make this object move downward is when the weight is greater than the sum of the two. So, we have upward force, forces, they are what? U, which is what? Upthrust, plus viscosity or frictional force. Then we have downward force. Which is what? The weight of the object. W. Now, for this object to move downward, it means this weight must be greater than sum of this. Therefore, when you find the difference, you are going to get the weight, the difference in weight at which the object is moving downward. So you are going to have W minus open bracket U plus V must be equal to the weight at which the body is moving downward, which is MA, mass of that object multiplied by acceleration. Don't forget, this acceleration is linear, while this one is what? Acceleration due to gravity. Now, when the body is moving downward, it will get a stage that the body will be moving with constant velocity. So in that case, acceleration will become 0. Therefore, we are going to have W minus U plus V is equal to M into 0. under constant velocity, acceleration is equal to 0. When we say constant, we mean uniform. That is, both initial and final are equal. So therefore, we are going to have weight minus u plus v is equal to 0. So in this case, what we are trying to say is acceleration is equal to 0 under uniform velocity, and that uniform velocity means body has attained terminal velocity. Acceleration is equal to 0, then the net force, that is addition of upward and downward, is equal to 0 as well. Now let's see the nature of the graph. When we plot the graph of velocity of that body against time, we have this. This is v, velocity in meter per seconds, while this place is time in seconds. So at initial stage, when velocity is increasing, we are going to have the nature of the graph like this. But when you get a stage when velocity remains constant, it will move like this. And at this stage, we call it what? Terminal velocity. Terminal velocity. Now, what is the effect of temperature on a viscous liquid? When you increase the temperature of a viscous liquid, it means you are reducing its viscosity. You are reducing its viscosity. But when you reduce the temperature, you are increasing a viscosity. That's why when you see most of the time, when you heat our red oil, which is one of the viscous liquid, you are reducing the what? Viscosity of it. Now, apart from that, the next topic will be fact about liquid. Viscosity. What are the facts about viscosity? So we have these 4 major facts about viscosity. I said viscosity depends on surface area. And don't forget, our frictional force, solid friction, does not depend on surface area, but it depends on nature of surface. Then, viscosity occurs in fluid, that is solid or gas. Then, it depends on relative velocity between the layer of the fluid. Then, viscosity also depends on tangential force between the layer. Those are the 4 major facts about viscosity. Then, what are the similarities between viscosity and solid friction? Don't forget, both of them, they depend on nature of material. They depend on nature of material. In our previous class, under friction, we said friction depends on nature, but does not depend on area itself. Then, this one also depends on nature of area. Then, both of them, they comprise of force which oppose motion. They comprise of force which opposes what? Motion. So both forces, both in solid friction and fluid, oppose motion. Then we have difference between viscosity and friction and solid friction. We have I wrote almost 4 here. Friction does not depend on area, surface area, while viscosity depends on surface area. Then, friction does not depend on relative velocity, as we have it here, while viscosity depends on relative velocity between layer of liquid. Then, friction occurs in solid, while viscosity occurs in liquid and gas, or we can say it occurs in fluid. Friction depends on normal reaction. That is from where we derive the formula that says friction F is equal to mu R under friction. But under viscosity does not depend on normal reaction. So that is where we are stopping for this. Next topic will be on upthrust and density.